Okay, so previously kita dah belajar ada dua jenis bond breaking such as homolytic cleavage and heterolytic cleavage. Homolytic cleavage akan menghasilkan free radicals. Heterolytic cleavage akan menghasilkan cation dan anion. The products of the cleavage, the bond breaking tu, kita panggil dia sebagai reaction intermediate. So, apa tu reaction intermediate? Reaction intermediate adalah chemical species yang di mana species tu dia berada kat tengah-tengah tau. Dia macam either one step ahead nak jadi product ataupun one step backwards nak jadi reactant. That's why we call it as intermediate. And ada tiga jenis reaction intermediates that I want you to look at and focus on, which is free radical. Free radical ni terhasil daripada mana? Homolytic cleavage. Okay, and next is about carbocation ataupun dikenali sebagai carbonium and carbanion. Okay, and these two terhasil daripada heterolytic cleavage. All of these reaction intermediates are actually very unstable and highly reactive. Okay, so let's learn more about free radical reaction intermediate. Okay, free radical ni is a very reactive species with an unpaired electrons. Macam mana dia dapat unpaired electrons macam ni? It is because dia terhasil daripada homolytic cleavage. Okay, homolytic cleavage di mana kita break the bond between two atoms equally. Kiranya each of the atoms akan dapat satu saja elektron. That's why dia jadi unpaired electrons lah. Kita panggil dia sebagai free radical. Okay, a radical is actually very reactive because dia akan tercari-cari elektron untuk completekan dia punya octet. So that's why free radical adalah very reactive reaction intermediate. Alright, and the next reaction intermediate that I want you to learn about is carbocation ataupun dikenali sebagai carbonium ion. So basically, carbocation ni adalah reaction intermediate yang a very reactive species with a positive charge on a carbon atom, and dia dihasilkan daripada heterolytic cleavage. For example, kalau you ada organic compound di mana kita nak buat bond breaking between two different electronegative atoms. Okay, this is a polar bond. Macam mana you tahu polar bond? Because carbon Cl atom ni dia punya electronegativity dia different. Okay, Cl is a more electronegative atom compared to carbon atom. So bila you nak buat heterolytic cleavage, it must be between two different electronegative atoms. Okay, and satu tu mestilah more electronegative atom compared to the other one. So bila kita nak buat the bond breaking, okay, kita akan buat bond breaking secara heterolytically. So bila kita buat heterolytic cleavage, kita akan gunakan double headed arrow. Di mana kita nak show kat sini akan ada salah satu atom akan menerima kedua-dua elektron dekat bond tersebut. In this case, since that Cl is a more electronegative atom compared to carbon, therefore dia akan dapat kedua-dua elektron tersebut. So untuk show yang Cl atom ni dapat kedua-dua elektron bila dia buat bond breaking ni is by showing it with this double headed arrow. Sebab nak show yang Cl atom ni dapat dua elektron. So bila Cl atom ni dapat dua elektron bila dia buat bond breaking secara heterolytically, this Cl atom will be Cl minus ion. Dia akan jadi an ion. Carbon atom ni bila dia lose dua electrons ni daripada bond breaking heterolytically ni, dia akan jadi carbocation sebab dia akan dapatlah positive charge. Dia akan jadi cation. Tapi because this carbon yang dapat the positive charge, that's why we call it as carbocation. Okay. Okay, the next reaction intermediate that I want you to learn about is carbanion. Apa tu carbanion? Carbanion ialah a very reactive species with a negative charge on a carbon atom. Okay, itu pun dia terhasil daripada heterolytic cleavage. For example, kalau you nampak this kind of organic compound, di mana you nak break the bond between atom yang less electronegative. Okay, and this carbon automatically akan jadi more electronegative atom lah. Contoh less electronegative atom Li dekat group 1 dengan group 2, itulah dia less electronegative atom. Okay, kalau dia berpasangan dengan less electronegative atom such as Li, okay, makanya dia akan menjadikan this carbon atom more electronegative atom. So again, bila kita nak buat bond breaking heterolytically, the one yang more electronegative atom tu akan jadi anion. Dia akan receive 2 elektron daripada bond breaking ni. Okay, so to show that this carbon atom, bila nak buat bond breaking, to show that this carbon atom akan receive 2 electrons, kita kena show it by using this double headed arrow daripada bond kepada carbon atom. Sebab kenapa? Just because of dia punya pasangan dekat bond ni less electronegative atom, that's why dia akan jadi more electronegative atom. So now, since that carbon ni dia boleh buat bond breaking, dia terima 2 elektron, makanya dia akan jadi carbon yang ada negative charge. So carbon yang ada negative charge, we call it as carbanion. Okay, this Li atom, dia akan dapat positive charge because they lose 2 electrons dekat this bond. So dia akan jadi cation species lah. Okay, this is all happen just because this carbon dia berpasangan dengan less electronegative atom. Alright. Okay guys, so previously we have learned about 3 reaction intermediates such as free radical, carbocation dengan carbanion, and also I've already taught you guys macam mana nak recognize carbocation and carbanion, right? So basically in this part, you need to know the inductive effect of alkyl groups on those 3 reaction intermediates. Okay, so basically ketiga-tiga reaction intermediates yang kita dah belajar tadi, carbocation, carbanion dengan free radical, okay, both 3 of them can be classified into primary, secondary and tertiary reaction intermediates, and it is all depends on the number of alkyl group yang bonded to them. Nanti kita akan belajar lah further macam mana nak kenal pasti dia adalah primary ke, secondary atau tertiary reaction intermediates. Okay, so you just need to remember this. It all depends pada alkyl group yang bonded kepada reaction intermediates tersebut. Okay, and then next, apa tu inductive effect? Inductive effect adalah electron donating effect. Okay, yang ni adalah keyword yang I want you to remember. Inductive effect adalah electron donating effect. The rest of it, I don't really care kalau you tak ingat sangat pun. Okay, so kalau let's say if you want to know further what is inductive effect, is actually the pool of electron density through sigma bonds ataupun through single covalent bonds yang caused by electronegativity or charge difference of atoms. Okay, basically you just tahu ni je lah electron donating effect tu. Alkyl group dia ada electron donating effect. Ingat lagi tak kita ada belajar awal-awal time 4.1? Okay, alkyl group ni ialah hydrocarbon yang jadi substituent. Okay, so dia ada electron donating effect. Nak bagi tahu kat sini, kalau let's say you letak let's say this reaction intermediates for carbocation dengan free radical, lagi banyak alkyl group, lagi banyak number of carbon atoms yang attach pada carbocation dengan free radical, dia akan jadi lagi stable. Okay, sebab carbocation dengan free radical dia suka electron donating effect. Alright, so the greater the number of alkyl groups on the carbon atom dekat carbocation and also carbon free radical, the greater the stability of the reaction intermediates. But carbon anion dia tak suka electron donating effect. Okay, so lagi bertambah banyak carbon atoms dekat carbon anion, lagilah dia jadi tak stable. Okay, so macam mana kita nak belajar pasal stability of carbon free radical? We need to know the class of the free radical. Okay, the class of the free radical boleh diketahui by the number of carbon atoms atau the number of alkyl groups yang attach kepada carbon free radical tersebut. Okay, so kat sini we can see that this is a methyl carbon free radical because this carbon free radical dia dikelilingi dengan hydrogen atom sahaja. Kalau if I want to condense this structure, it will look something like this. Okay, CH3 dengan ada satu saja unpaired electron kat situ. Okay, this is actually a primary carbon free radical sebab this carbon free radical is attached to only one alkyl group. Alkyl group ni contohnya macam CH3 ke, CH2, CH3, anything yang kita dah belajar dekat 4.1 pasal alkyl group in hydrocarbons. It can be methyl, it can be ethyl, it can be isopropyl. Okay, pokok pangkalnya alkyl group ni mesti start dengan carbon atom. Okay, so kalau let's say you nampak carbon free radical dia attach pada satu sahaja carbon atom atau satu sahaja alkyl group, tak kisahlah alkyl group apa sahaja pun, we call it as primary carbon free radical. Okay, next the next class of the carbon free radical adalah secondary carbon free radical. Okay, di mana this carbon free radical is attached with another two alkyl groups. Okay, dia attach dengan dua jenis alkyl group ataupun dua carbon atoms lah. Okay, and the last class of the carbon free radical adalah tertiary carbon free radical, di mana this carbon free radical akan attach with another 3 carbon atoms. Kalau let's say dia attach with another 3 alkyl groups ataupun 3 carbon atoms, we call it as tertiary carbon free radical. So kita boleh nampak kat sini lagi banyak alkyl groups ataupun lagi banyak carbon atoms yang bonded to this carbon free radical, makanya dia punya stability will be increased. Sebab kenapa? Okay, previously bila kita belajar pasal free radical punya reaction intermediates, we know that free radical ni is very reactive. Sebab kenapa? Sebab dia ada unpaired electron. Okay, so dia akan tercari-cari elektron yang nak completekan dia punya octet. So, alkyl group ni ataupun alkyl groups ni ataupun dikenali sebagai electron donating group, okay, dia ada electron donating effect ataupun dikenali sebagai inductive effect. So, bila dia ada electron donating effect, okay, dan hanya ada electron donating effect saja, so dia akan menyebabkan this carbon free radical rasa macam cukup. Sebab dia kan jadi unstable sebab dia ada unpaired electron, tapi bila dia pair dengan alkyl group, dia rasa macam cukup. Sebab kenapa? Alkyl groups ni dia ada electron donating effect. Bear in mind, alkyl groups ada electron donating effect, so dia akan rasa cukup. That's why dia akan stabilize the carbon free radical. Kalau let's say ada banyak alkyl groups yang keliling the carbon free radical, lagilah dia rasa happy sebab dia rasa lebih-lebih daripada cukup. Okay, sebab kenapa? Sebab the reason why is alkyl groups dia ada electron donating effect. Okay, makanya dia akan stabilize the carbon free radical. Lagi banyak alkyl groups yang attach pada the carbon free radical, lagilah dia stable. Okay. Okay, so how about the relative stability of carbocation? Okay, you can refer the stability of carbocation with carbon free radical. Okay, sebab carbocation ni pun dia macam tak cukup elektron juga, because bila dia buat heterolytic cleavage, okay, this carbocation dia dapat plus sign sebab bila dia buat heterolytic cleavage, dia berpasangan dengan atom yang lagi elektron negatif. So bila dia buat heterolytic cleavage, okay, makanya dia akan lose 2 elektron kat situ. So dia macam tercari-cari juga electrons yang akan lengkapkan dia. Okay, and also the class of carbocation pun ada 4 kat sini. This is the methyl carbocation. Methyl carbocation ni ialah kalau you ada CH3, dengan ada positive sign kat situ. So this is methyl carbocation. Okay, primary carbocation ialah bila this carbon with this positive charge is attached to only one alkyl group. Okay, so that's why we call it as primary carbocation. Kalau dia attach pada satu carbon atom, kita panggil dia primary carbocation. Kalau this carbocation, dia attach to another two carbon atoms ataupun two alkyl groups, we call it as secondary carbocation. And lastly, this carbocation is called as tertiary carbocation because it is attached to another three carbon atoms ataupun three alkyl groups. Okay, and the stability increases as the tertiary carbocation just because alkyl groups dia ada electron donating effect. Okay, you need to remember this. Alkyl groups dia ada electron donating effect yang akan stabilizekan the positive charge on the carbocation. Okay, so lagi banyak alkyl groups dekat this carbocation, lagi stable lah carbocation tersebut. Okay, lastly, how about the stability of carbanion bila let's say dia ada alkyl groups around it. Okay, this is methyl carbanion. Carbanion dia terhasil bila you buat heterolytic cleavage and bila your carbon tu dia berpasangan dengan less electronegative atom lah. Contohnya macam Li, Na, okay. So bila dia buat bond breaking, okay, this carbon akan terima dua elektron tersebut. So that's why dia jadilah carbanion. Okay, so this is contoh methyl carbanion. Kalau I buat condensed structure for methyl carbanion, I will get CH3 with negative charge. This is methyl carbanion, okay. And the next class of carbanion ialah primary carbanion, di mana this carbanion dia attached with one alkyl group, okay. And then next ialah secondary carbanion, where this carbanion is attached with another two alkyl groups. And lastly, this is a tertiary carbanion because it is attached to another three carbon atoms ataupun three alkyl groups. Basically, okay, carbanion ni dia terhasil sebab dia terima dua electrons kan bila dia buat bond breaking ni. So dia adalah spesies yang ada extra electron, so that's why dia ada carbon minus kat sini with negative charge. Alkyl group ni dia ada electron donating effect. Okay, so benda ni dia dah kaya. Bayangkan carbon ni dah kaya. Lepas tu elektron alkyl group ni ada electron donating effect. Dia lagi mengaya-ngaya kan, lagi kaya-kaya kan this carbon ni. So carbon ni tak suka. Macam tu lah, carbon ni tak suka. Sebab dia dah kaya, dia macam ada extra electron. So alkyl group ni ada effect yang menyebabkan dia ada electron donating effect. Okay. So macam dia tak suka lah dikelilingi dengan electron donating effect ni. Sebab yelah dia dah kaya. Kalau dia tak cukup kaya macam carbocation dengan carbon free radicals tu lain lah. Tapi dia dah kaya, so dia tak perlukan bantuan electron donating effect untuk mencukupkan dia. Okay, cumanya dia kalau let's say dia dikelilingi dengan electron withdrawing groups, kalau let's say instead of alkyl group dia dikelilingi dengan electron withdrawing group such as halogen, macam contohnya chlorine ke bromine, iodine, dia sukalah, dia lagi stable lah sebab dia macam extra kan. So nak bagi tahu kat sini, kalau carbanion dia lagi banyak alkyl groups yang attach pada this carbanion, lagi dia unstable. So let's look at this exercise. Justru kamu explain the meaning of free radical, carbocation and carbanion. So please look up at my slides on the reaction intermediates for free radical, carbocation and carbanion. So here's the answer. Free radical dia terhasil daripada homoelectric cleavage and it's a very reactive species with an unpaired electron. Carbocation pula dia form in heterolytic cleavage. Tapi dia very reactive species with a positive charge on a carbon atom. Carbanion pun dia terhasil daripada heterolytic cleavage, tapi dia adalah spesies yang ada negative charge on a carbon atom. Okay, so the next exercise, dia suruh kamu explain kenapa the order of carbocation punya stability adalah tertiary carbocation lagi stable daripada secondary dengan primary carbocation. Tetapi kalau the order of stability in carbanion pula, primary carbanion dia lagi stable daripada secondary dengan tertiary. Okay, so first thing first, when you want to explain this kind of thing, you have to relate it dengan point yang melibatkan R. R ni adalah alkyl group. Alkyl group ni ialah electron donating group yang mempunyai electron donating effect. Okay. Dia macam ada aura menderma macam tu, menderma elektron. So dia macam seorang yang pemurah begitu. So next ialah you kena faham carbocation tu macam mana dia terhasil, carbanion tu macam mana dia terhasil. Okay, carbocation dia terhasil daripada homolytic cleavage, di mana bila dia buat bond breaking tu, dia berpasangan dengan more electronegative atom. Jadinya more electronegative atom tu akan dapat 2 elektron. Carbocation ni dia akan lose 2 elektron, so that's why dia dapat positive charge kat situ. So dia macam dia tak cukup elektron kat situ ya. So bila dia tak cukup elektron, dia sukalah bila dia dikelilingi oleh orang hado-hado dengan penderma ni, which is dikenali sebagai alkyl group. Sebab alkyl group ni dia ada electron donating effect, dia ada aura menderma elektron macam tu yang menyebabkan carbocation ni rasa secure. So carbocation dia memang suka alkyl group. Tapi carbanion ni terhasil daripada heterolytic cleavage bila dia berpasangan dengan less electronegative atom. So dia akan dapat 2 elektron bila dia buat bond breaking. So carbon anion ni dia adalah C minus sebab dia terima 2 elektron bila dia buat bond breaking. So dia macam terlebih elektron sudah. So bila terlebih elektron, dia tak suka dengan alkyl group ni. Dia tak suka dengan group yang hado-hado ni, yang macam boleh buat dia rasa yang ada aura menderma elektron ni. So carbanion memang tak suka electron donating effect. So dia akan jadi lagi unstable bila dia dikelilingi oleh alkyl group. So how can you explain it? You can say something like this. The stability of carbocation increase with the number of alkyl group present. Okay. So lagi banyak alkyl group yang mengelilingi this carbocation, lagi dia stable. So that's why tertiary carbocation dia lagi stable. Okay. Sebab kenapa? Sebab alkyl groups ni dia ada electron donating effect, so dia akan help to stabilize the positive charge on the carbocation compared to carbanion. So that's how you answer it.